Great. So our plan for today is we're going to do your 6.3 notes, which are the graphs of the reciprocal trig functions. The note sheet that I handed you is stapled together, correct? Rip it apart, crumble up the second page, and we are not doing the inverse functions, okay? So those you can totally omit. We're only doing the 6.3 notes, just the front and the back of the first sheet. Okay, so if you want to discard those, you're more than welcome to. You're going to want, again, a graphing calculator in front of you. Tomorrow, we're going to review chapter 6, and then you have a short test on Friday. Okay, and then after Friday, we begin midterm exam review. Okay, so over to your document that says 6.3 at the top. And again, just to repeat that, we're going to do this first page. We're going to do the second page. In page 3, you can rip that out and throw it away. So again, we are not doing those inverse trig functions. We are only going to look at just your reciprocal, okay? The inverse ones you will see next year when you take calculus anyways. Okay, so I'm going to start right here at the top. So it's a big calculator day as well. So the first thing we're going to start with is just the graph of sine of x. And what is important when you leave this course and head into calculus next year is that you know what a sine and a cosine curve look like without typing them into the calculator. Okay. So sine of x has an amplitude of what? Of just 1. And same thing with cosine of x. So I'm going to do this before we set up your calculator. So sine of x only has to go to 1. So my graph will look nice. So I'm going to go 1 right here. And then I'll go 2. And then I'm going to go -1 and -2. You will notice that this particular axis is labeled in what? Degrees or radians? Degrees. So your calculator has to reflect that. Whatever the graph is labeled in, you should be too. So for these examples, we're going to put our calculator into degrees. And you want to be comfortable going back and forth between degrees and radians. So 90 degrees, you want to know that that's pi over 2. 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. So let's go to the calculator and get this set up. So the first thing I'm immediately going to check for in my calculator is the mode. And if your calculator is currently in radians, which if you borrowed one from the back of the room, it most likely is, you need to change it at this time into degrees. Now I'm going to go to the window. We've done this before. The x min is the smallest value on the left-hand side of your graph paper. What was the smallest value on the left-hand side of the graph paper? -360. Good. The largest was 360. And I'm going to scale this by 90 degrees. Now or if you want to go 45, you certainly could do that too. Because I know I'm looking at your graph paper right now. Actually, let's do that. I'm going to change this to 45. Then it's exactly what's in front of you. All right, our y min was equal to -2. And the y max was equal to 2. And we scaled ours by 1/2. Is everybody there? Okay, now you're going to go to y equals, and you're going to type in sine of x. And again, this should be at this point familiar to you. It looks like that. Okay, so I'm going to translate that onto my paper. All right, so my graph. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360 is 0. And it's just personal preference, but I like to do this side of the graph first, and then we will create a exact replica on the other side. All right, so over here and back up all the way through this. All right. And again, there is your sine curve. Now what you need to do is state your domain and your range. And I will give you some options here as well. You can pick what you prefer. So the domain for a sine graph, you notice how it has no restriction to it? So when we have a graph that has no restriction to it and it goes on forever, you can just say that this is all reals if you'd like. Or those of you that favor the interval notation, you can say that this goes from -infinity to infinity. I don't know, I think that's probably easiest stuff. Now I need to go and find my range. And my range is my y values. Would you agree that this is only going to be in between certain values? Okay, what's the smallest y value? -1, biggest is 1, so it's between those. So option number 1. Those of you that favor interval notation, you can do this. Your other option is you can write this as an inequality. So alternatively, I could go -1 less than or equal to y, less than or equal to +1. Okay, it makes no difference. So when you take your test Friday, you can list it however you prefer. And again, when you did this a couple chapters back, I kind of saw you basically 50% of you guys going each way. So I'll keep doing it both ways, pick what you like. All right, so now we're going to do a cosine graph. And again, this one is also not new to you. You've done it before. So you're going to go right to the calculator. You're going to change it to cosine of x. Cosine of x. Also, just like sine has an amplitude of 1. So I am not going to change how my graph is written here. So I am going to start right at 1. And then 0. And then -1. And then 0. And then up at 1. And then I'm going to go right through this. So you want to be really comfortable with what a sine and a cosine graph look like. Over this way too. And I'm just creating an identical image. Again, your trig functions are periodic in nature. There you go. Now I'm going to write the domain and the range for the cosine function. So my domain here, does it have any restriction to it? It does not. Good. So domain, I can quite simply just say again, all reals. Now my range. Does this have restriction to it? Is it in between values again? It is. So option number 1 is you can do the interval notation with a square bracket. This goes from -1 to +1. Alternatively, you could go -1 less than or equal to y, less than or equal to 1. Okay, so whatever notation you favor. Now, moving on to number 3. So here's where these are new today. You have y is equal to cosecant of x. What type of trig function is that called? A reciprocal. Good. So this is a reciprocal function. And what does cosecant go with? It's a reciprocal of, yep, perfect. So I'm going to actually put something on here first. So you can just use your pencil and then you'll be able to see how cosecant differs. So I'm going to just throw on a basic sine curve here, just very lightly. So a sine curve, and again, this is to really reinforce those and make you familiar with it. All right. So here's sine of x. This is just sine of x. I'll color coordinate that. And then we're going to graph your reciprocal, which you are still able to use your calculator to do. All right, so to do cosecant of x, I'm going to go right into the calculator, and I'm going to type y is equal to 1 divided by sine of x. Now, I don't know if you remember back, it's been a couple of weeks, but cosecant of x is going to have some values for which it is undefined. So you're going to see how that translates into your graph here. So I'm going to go to my y equals, and I'm going to type in 1 divided by sine of x, and I'm going to hit graph. Everyone get this image? Okay. Again, your cosecant graph has values for which it is undefined. That's why I had you grab colored pencils from the back. So what we're going to do is use colored pencils and draw in your vertical asymptotes where that function does not exist. So first place I'm going to start with is a 0. And then it looks like right here, if I hover on this right here, this is halfway. So we've got 180. And then I've got another one at 360. And then same thing on the left-hand side. So I'm going to first take my graph and place all my asymptotes in. So I'm going to do all of those in green. So asymptotes were located at 0. And these asymptotes are only going to apply to your cosecant graph. So you can ignore the sine one on your paper right now. So here's another asymptote. And another. And I'm going to go back on the left-hand side as well. And I'm going to go negative 180. And negative 360. And those are going to help you sketch your graph in a moment. Now, your question right here asks you, why cosecant of x is undefined where? Do you see all 5 locations? So on this particular graph, we are undefined at, actually, you know what, I'll do this just to make this easier for you. Plus and minus 360. Plus and minus 180, as well as 0. Okay, so all of those locations. Now if you create your picture, what you're going to notice is a little, I don't know if I want to call it a pattern, but when you go back to your calculator, you're going to see right here, this value that I'm hovering on, that is equal to 1, and this one is equal to negative 1. And it's going to kind of go the opposite direction of that sine curve that's on your paper. So my cosecant graph, I'm going to do this one in blue. And you're going to notice it does this. Same thing. And next side. And one more. I'm going to take this like so. So now what I need to list is the domain in the range for cosecant. I'm going to do domain and range now. Now, unlike a sine curve, Your cosecant function, does it have restriction to it? It does. It has many restrictions to it. So I'm going to say all reals except x cannot equal. Let's look for a pattern to this, okay? So x can't be 0, x can't be 180, x can't be 360. So what we say, so this is pi, this is 2 pi, and then I would have another as well. So it cannot be equal to a multiple of, you could say pi, or you could say 180. Right, because it can't be 180, it can't be 360. And if you keep adding 180 forever, it's going to be undefined at all of those values. So x cannot be a multiple of 180 degrees. Now your range. Does the range have restriction to it? It does. So my range, I'm going to start at my small one right here at -1. So it's -1 and then it goes below that. So your first option here, if you favor the interval notation, is I can say that this is from -infinity all the way up to -1. Or I can say that it goes from 1 up to infinity. And infinity is always going to have the rounded bracket left. If you don't like that, you can do the inequality as well. So your other alternative is you can say y is less than or equal to -1, or y is greater than or equal to +1. Again, it makes no difference to me. You can use either or. How is that reciprocal function, okay? So again, it's just right off your calculator as well. So next, when you flip, we're going to do a tangent function. Does anyone remember this tangent have places where it's undefined? It does. So my window is still the same, so you don't have to make any changes there. So we're going to go right back to the calculator and we're going to type in tangent of x. So I'm back to the calculator and I'm going to do a tangent function. And continue. So it looks just like this. So the first piece of advice is let's put in the asymptotes. So your tangent function cannot exist right here where I'm hovering at 90. And then another one over here at 270. 90 and 270. So back over. So I'm going to go 90 and 270. Place your asymptotes in there. And then I'm going to go back to the other side as well. And I'm going to go -90. And -270. Okay. So places where tangent is undefined. So if you want to list them all out again, you could, or I'm just going to shortcut it and go this. And 270. And now we're going to sketch this. So I'm going to take a different color. You're at 0. And then it's going to go up, approach your asymptote like so. All right, so right down through here. And again, what you want to do when you sketch this is you want to approach the asymptote, but not cross it. So I'm going to come up and through. And then again, on the other side here as well. Back over here. Again, approach your asymptote without actually crossing. And back through. And once more. Hold on a second. Backwards, that's what I thought. Don't copy that last one. I was gonna say. Should be better. Okay, so now we need your domain and range for this. So here, obviously, you have different values where this is restricted. So my domain is going to be all reals except, I'm going to say reals except. I'm looking for where it doesn't work. So it doesn't work at 90. Doesn't work at 270. So again, 90 is pi over 2. 180 is 3 pi over 2. So what we say is it does not work at odd multiples of pi over 2. So except x cannot be equal to an odd multiple because it goes 1, 3, 5. So of pi over 2, which again is 90 degrees. Okay. So again, it couldn't be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And you can continue that forever, plus and minus. Okay, so that kind of covers your basics there by saying multiple can't be an odd multiple pi over 2. All right, your next function, secant goes with which trig function or its reciprocal. Yep, cosine. Good. So we're going to do a cosine graph on here first, and then we'll see your secant graph. So cosine. So I'm at 1, 0, -1, 0, 1. So this is your cosine graph. Again, just do this one really lightly in pencil so you got it. And then this way too. I'm going to go 0, -1, 0. Okay. So that one is just y equals cos of x. Now I'm going to go to the calculator and we're going to graph secant of x. All right, so to do secant of x, you're going to type in y is equal to 1 divided by cos of x. And are there places where secant is also undefined? Yes. So back to the calculator. I'm going to change this to 1 divided by cosine of x to graph the reciprocal function. And you've got this image right here. So that's what you're going to place on your paper. And we need to draw in these asymptotes. So you have asymptotes at 90 degrees, 270. So it's essentially the same asymptotes as your tangent graph. Let's throw all those in first. So we want to be asymptotes at 90. And again, these asymptotes only apply to the reciprocal function, not the original cosine function. And one more. Okay, so now you're going to look at your graphing calculator and we're going to create this picture. So we are going to do this one in orange. All right, so we're going to take this right here up this direction. All right, next side, I'm right down here. And I want one more. So I've got just this part right here. All right, back to the other side. And again, this side can be sometimes helpful to have your original function on here too. So I'm going to go right down through. And same deal. So we need to write out where this is undefined and then domain range. So secant is undefined at plus and minus 90, plus and minus 270. As they appear on your paper, and domain. So my domain is all reals, except x cannot be equal to an odd multiple again, because 1, 3, 5, of 90 degrees, which is pi over 2. Again, I like you to write both just because often you will in the future see a lot more trig graphs and done in radians too. All right, my range. My range is going to look very, very similar to the reciprocal of your sine graph. So my range, again, you got options here. I'm going to say, I think I did interval first on the other one. So my range is from negative infinity all the way up to -1. And then it jumps, picks back up at 1, continues to infinity. So that's option number 1. Option number 2, I can say y is less than or equal to -1, or y is greater than or equal to positive. All right, any difficulty getting those reciprocals? Okay. So lastly, we need the reciprocal for cotangents. I'm actually not going to have you put tangent on this one too, because tangent already has all those asymptotes, so this is going to get very cumbersome if you have both graphs on the same axis. So let's just do cotangent. So cotangent in the calculator, you're going to type in 1 divided by tan of x. And again, start with the asymptotes. So start with your asymptotes here over to the calculator, and so I'm going to go 1 divided by tan of x. And graph. Everyone get that? Kind of looks like the opposite of the one you just did above. So I need to place asymptotes at 0, 180, oh no, yes, 180 and 360. All right, so back to my other documents. Okay, so I said 0, which is 180. 180. And 360. And negative 180. And negative 360. All right, so what are we undefined here? 0. Plus and minus 360. Plus and minus 180. And then again, just remember that 180 is pi, so 360 is 2 pi. So your graph should look like this. Again, you can copy it right off your calculator. No need to memorize any of that. So now we're going to go this direction instead. And next side as well. So at 270, I am at 0. Obviously, if you wanted to include more points, all you do is go to your table of values and grab some more of these. And I'm here. And back through as well. Great. So domain and range from last. So my domain, does it have restriction to it? It does. So domain is going to be all reals except. So again, you would have an asymptote at 180, at 360. If you kept adding 180, would you still have asymptotes? Yes, you would. So I'm going to say except multiples of 180, which again is just pi. So again, it can't be 180, it can't be 360, it can't be negative 180, it can't be negative 360, and it extends forever. And then my range. Does your range have any restriction? It does not, so this is just all reals. Okay, so that includes everything. All right, how do we feel with calculator work with the reciprocal function? Pretty good? Your homework, I hope you have this sheet. What you're going to find is this one. And what you should absolutely do is you need to start with 10, 11, and 12 first so that you can get the answers on the left-hand side by looking at the graphs. So please start with 10, 11, and 12. And anything I didn't make you graph on this sheet, so you're graphing the sine curve so you can get those answers. Graphing a cosine curve, graphing a secant curve. So what you'll do is once you have your secant graph again, the secant of 180 right here, all you have to do is look at the graph and see what value that gives you. Same thing with everything 7, 8, and 9. So refer to your pictures. These answers on the left-hand side, they don't require any work. All you do is look at the graph and figure out where is sine -1. So I'll help you out with that one. So number 7, sine of theta is -1 where? So I flip that. Oh, sorry. And where is sine -1? Right here. So that answer would be 270. Or couldn't you also say -90? Yep. So that's how those work. You just use the graphs to get those answers. So that sheet is homework. Again, refer to your pictures if you need any more than 3 right here. And then tomorrow we review. Friday is your test. You don't. Okay.